Welcome IGCSE Year 10 students. Today we're looking at using Pythagoras Theorem to find the distance between 2 points. Now remember last year when we did Pythagoras Theorem, we realized that when we had a right angled triangle, and please pretend it's a right angle, and we had sides A, B and C, we knew that the C squared would be equal to A squared plus B squared. That's Pythagoras theorem, and therefore C would be equal to the square root of A squared plus B squared. Now, I want you to imagine that we know a point is here and a point is here. What we can do is we can find the x change, so how far we've gone in this direction, x, and then the y change, how far here, and we can square both of those, add them together, and find this square root of that to find the distance from here to here. So let's take a look at this here, AB, the length of AB, and we can actually just say modulus AB, could go like this, but I'll just go AB squared is equal to, now how far have we gone x value? We've gone across 2, and then up here 1, 2, 3, 4, 5, right? So these are right angled triangle, plus 5 squared. And so AB, the length of AB is going to be the square root of 2 squared plus 5 squared. And so that's 4 plus 25, so it's going to be the square root of 29. And I guess you can simplify that to 3 significant figures if you want to, 5.39. Okay, let me do another example for you here. Let's think about CD. So what's the distance between C and D? Well, you've got your right angled triangle here. So CD is going to be equal to the square root. Now let's look at the change in y. So it's we've gone down 3, so minus 3, but we're going to square it, make sure we've got the brackets there, and then we've gone across 2, so it's positive 2 squared, which is the square root of 9 plus 4, which is square root of 13, and I guess we can write that as 3.61 to 3 significant figures. Oops. Now, you can also use the same logic even if you don't have a drawing. Okay, so let's say you're given 2 points. So they give us some points in number 2. So let's see, they give us 2, negative 4 and 6, 3. Now, what is the distance between these 2 points? Well, you can think about it. I'll just do a very rough sketch to give you a general idea. So 2, negative 4 would be, say, down here, and 6, 3 would be here. Right, we want to find the distance between those points. Well, what we can do is we could imagine a right angled triangle like that, can't we? And this is the x change, and this is the y change. So how have we changed in x's? We've gone from 2 to 6, which is 4, isn't it? So the distance will be the square root of, we can go 6 minus 2, which is 4, squared, plus now the distance in y, we're going to take that 3 and find the difference between that and minus 4. So 3 take away minus 4. And you can see that that's going to be positive 7, isn't it? Because from minus 4 to 0 is 4, and then up 3 more is 7. So you're going to square that. And then what do we get? 6 minus 2 is 4, so that's square root 16. And then plus 49. So we should have square root 65, I think. And that gives me 8.06. Now you want to get to the stage where you don't need to do a drawing. So let's do another example. Let's say we're 2e So for 2e, we've got negative 9, comma 2, and 1, comma negative 4. Now, the distance between these points is going to be equal to the square root of, and we'll find the distance between the x values and square it. So 1 minus 9. So the distance between those x values is 10. We square that. Then we find the distance between the y values. And we square that. So we get the square root of 10 squared plus negative 6 squared, which is equal to the square root of 136, which is equal to 11.6 or 11.7 to 3 significant figures. I hope this is making sense to you. So in summary, and I do expect you to try some of these on your own. In summary, distance between 2 points, we can think of it this way. So if we've got a point x1, y1, and x2, comma y2, the distance between them will be the square root of x2 minus x1 squared plus y2 minus y1 all squared. So that's what you're going to do for that. Now the second thing we're looking at today is Pythagoras when we're dealing with when we're dealing with 3D examples. Now this first one, this is exercise 2.17, I'm meant to be finding the distance between A and G. So I want you to imagine that there. Okay. Now, how am I going to find that? Okay. Well, what I'm going to first do is I'm going to find the distance between A and C. Okay. Now I want you to imagine that is a triangle. Here's A, here's C, and here's B. And it's a right angle triangle because ABC is right angle. We know that AB is 8, and we know that BC is 1, and therefore we can work out AC. So AC is equal to the square root of 8 squared plus 1 squared is equal to the square root of 65. Now I'm going to leave that as it is for now. So now I know I've got another triangle and I know the two things that I need to get them. So if you think about now triangle ACG, here's A, here's C, here's G. We know that ACG is a right angle triangle. We know that CG is 2. And we know that AC, we've just found it out to be square root 65, haven't we? And now I can find AG, which is what I needed to find. So AG is equal to the square root of 2 squared plus square root 65 squared. Now, obviously, square root 2 is 4, and square root 65, 2 squared is 4, and square root 65 squared is simply 65. So we end up with square root 69. And if we chuck that into 3 significant figures, we ought to get 8.31. So with these, you often need to do a few steps first. I think in most of them you're going to need to find AC first before you can find AG. Now the next one, my comment just previously was related to questions 1, A, B, C, and D. You might have to do a couple of steps. Now this next one, I'm trying to find AC, so I want to know, that length there. So again, I'm going to need to do some other work first. I'm going to need to first of all find this. And once I've found that length, the length of AF, you can see that I've got triangle AFC, and I can use Pythagoras there. So what I'm going to first do is use triangle ABF. So here's my triangle ABF. I've got a right angle here. I know that this is 12, and I know that BF is 5, and so therefore AF is equal to the square root of 12 squared plus 5 squared, which is equal to square root 144 plus 25, which is, I think that's 169, isn't it? And the square root of 169 is 13. So I know that that's 13. Now we can look at triangle ACF. Here's A, C, F. We know that F is a right angled triangle. We know that CF is 7. And we know we've just figured out AF is 13. So now we can find AC. AC is equal to the square root of 13 squared plus 7 squared. And so, what do we get there? We're looking at the square root of 218. And that gives us 14.8 to 3 significant figures. Now I've just got one more that I'll do with you. I do expect you to try, well, it'd be worth trying all of the questions. Now I'm trying to find the length of AP. Now, so what in essence I'm trying to do is make a triangle like that. And I know that PC is 2.5, and I need to find AC. So how am I going to find AC? Well, to find AC, I'm going to use triangle ABC. Here's A, here's B, here's C, 9, 6. Now we can find AC, so AC is equal to the square root of 9 squared plus 6 squared, which is equal to the square root of, what is that, 117? And square root of that is equal to 10.8. Now I'm going to actually use this answer in my next part so that I've got an accurate answer, because square root 117 is an exact answer. Now let's look at triangle ACP. Okay, we know that ACP is a right angled triangle where PC is 2.5 because P is the midpoint of CG, and we know that CG is equal to 5 because this is 5, so this must be 5. So therefore halfway is 2.5. We know AC is square root 117 because we found that in the previous question. And so now we can find out what AP is. So AP is equal to the square root of square root 117 squared, which is obviously just going to be 117, plus 2.5 squared. Now we chuck that into our calculator. What do we get? Final answer is 11.1 to 3 significant figures for me. Well, team, I hope that's been helpful to you. Hope it makes sense. Do let me know if you're having any trouble with any of these questions. I'm here to help. I want you to understand what you're doing here. So I haven't had many questions, so I look forward to them. Don't hesitate to ask if you're stuck. Alright, God bless, guys. See you later.